next section, 4.5, integration by substitution. Alright, let me show you the theorem 4.13. I didn't write a complete theorem, but just the important part here. You have an integral of a function f of something, and you have the inside function. And if you have the format that you have the derivative of the inside function, you can apply the integration here. Let's look at our first example. Alright, I have an integral. My function is 1 plus 6x to the fourth power. And if you take the derivative of 1 plus 6x, it's just 6 dx, alright? So it's fit the format perfectly. I have the function and the derivative of the inside. The derivative of the inside is the 6. So the integral of this is going to be 1 plus 6x. 4 plus 1 is 5 over 5 plus c. Alright, so let's look at the second example. The second example, I have an integral of square root 25 minus x squared times minus 2x dx. I'm going to rewrite square root as an exponential form, which is 25 minus x squared in 1/2. Alright, times 2x dx. So this is a function, and the derivative inside of this, the derivative inside is just negative 2x. So it's fit the formula perfectly. So I can just take an integral. I add 1 to exponential, and then I got negative 25 minus x squared raised to 3 over 2 over 3 over 2 plus c. And I rewrite this. So this is my answer. Let's look at the next example, example 3. Example 3, this is an integral of x to the cube times x to the fourth plus 3 quantity squared dx. Now if you look at my function here, x to the fourth plus 3 quantity to the second, the derivative inside should be 4x to the cube. I only have x to the cube. I need 4x to the cube. So what I'm doing here, I know that 4 over 4 is just 1. So anything times 1 is 1. But when I'm doing this, I end up with 4x, which I needed here. So I have 4x to the cube here. So I multiply by 1/4 and times 4. Next step I did is I take out the 1/4. Alright, everything remained the same. So it's fit the formula perfectly. I have a function and the derivative inside of a function. So I just take an integral of this. 1/4 is just 1/4. If I take an integral of a function, this function right here, I'm going to have power 2 plus 1, which is 3 over 3. I multiply the 4 and the 3, I get 12. And don't forget the plus c. Alright, the next one is not quite as simple as the first 3. I'm going to use substitution just to make it more clear. Again, the first 3 you can use substitution too, but I don't feel I just want to show you different technique. So let's say if you're going to use substitution, I let my u be sine of 3x. So take derivative of this, du will be cosine of 3x. Derivative inside is 3 dx. Then I multiply by 1/3 or divide by 3, same thing. Divide by 3, both side and left hand side and right hand side. Then I have this whole thing over here. This is the original integral function. So let's substitute it back to u. Sine square of 3x is just u square. Cosine 3x dx. Cosine 3x dx is 1/3 du. Next step I did is I take the 1/3, which is constant out. I end up with integral of u squared du. I have u du. Alright, so I take an integral of this. The degree will be 2 plus 1, which is 3 over 3 plus c. 3 times 3 is 9. I can't stop here because the original is not u. We have to substitute it back. So I have, I made a mistake. This just be 1/9 from here. Alright, so it's 1/9. My u is sine 3x, so side to the cube 3x plus c. Alright, let's look at next example. Alright, let's finish two more examples. Alright, the first example, evaluate an integral from 0 to 1 x times x squared plus 1 quantity to the third dx. I'm going to use the u substitution here. I'm going to let my u be this term. So u equal to x squared plus 1. Derivative of this, which is du, is going to be 2x dx. I divide both sides by 2, so I end up with 1/2 du equal x dx. Now this is our original equation. So my u is x squared plus 1, so u to the cube. X dx is just 1/2 du. Now the integral of x from 0 to 1, you cannot use 0 to 1 here because your variable changed to u here. So let's look at the lower limit. My equation is u equal to x squared plus 1. My lower limit for x is 0. So if I substitute 0 for x, I get 0 squared plus 1. So my u on the lower limit will be 1. Same thing as the upper limit. I will substitute 1 for my x. My upper limit will be 2. So be careful when you use your u substitution. You have to change your lower and upper limit according to your variable. So I use my u now. My lower limit will be 1. My upper limit will be 2. Next step is I bring out the constant, which is 1/2. Now I have 1/2, an integral from 1 to 2, u to the cube du. Take an integral of this. It's end up with u to the 4th over 4 from 1 to 2. There are two ways to do this, but let's continue. I'm going to use u. So substitute upper bound in 2 to the 4th is 16 over 4, 1, you get 1/4. 16 minus 1 is 15 over 4 plus 1/2 is 15 over 8. Now if you want to do another way, you can from here go down here. So you replace u by x. Whenever you replace u by x, your lower and upper limit have to go with the x, which is 0 to 1. So I have to change 0 to 1. So make sure you know your variable and the upper limit of your variable. And if you do this, substitute the lower and upper, you should get the same answer. Alright? Let's look at the next example. The next example, I have an integral from 1 to 2 of this whole thing here. I'm gonna let my u be this part right here. Alright? So my x would be, if you move things around, my x will be 2 minus u. Take derivative, the x will be minus du. Alright, this is the original equation. Again, you have a lower and upper bound. You cannot use 1 and 2. I don't have room here, but let's look at this. If your x is 1, your u will be 1. Alright? Your upper bound here is 2. If your x is 2, 2 minus 2 is 0, so will be 0, your upper bound. My x, I have to rewrite everything in terms of u. My x, I cannot use x, so my x is equal to 2 minus u. So I have 2 minus u here. And minus 1 is just minus 1. Again, 2 minus x is my u. So u, I changed from radical to exponential. My dx is minus du. So I changed all the x to the u. Now this is one way, but you don't have to do it this way. But for me, lower limit should be slower than upper limit. It should be something small to something big. So I use from lower limit, I reverse it. So 0 to 1. If you reverse the lower and upper limit, you must have a negative here. This is from definition in section 4.3. Alright? Let's see, what else did I do? Okay, 2 minus 1 is 1, minus u, everything else remain the same. Now I have negative here and negative here has become positive. So it's just positive. Next step I did is I distribute the u to the 1/2 to 1, I get u to the 1/2. I distribute u to the 1/2 to negative u, then I have minus u to the 3 over 2. Let's see, next step I take an integral of u to the 1/2, you just add 1 to it, so it's 3/2 divided by 3/2, minus u to the 3/2, you add 1 to it, it's just 5 over 2 divided by 5 over 2, and your lower bound is 0, your upper bound is 1. Substitute your upper bound, 1 to any square or fraction is just 1, so I have 2/3. Same thing here. And the lower bound is just 0, so it's minus 0. The LCM is 15, so it's 10 minus 6, which is 4 over 15. Alright, we just finished 4.5, and I'll see you again later.